Hello guys, welcome once more. My name is Dami, and in this edition we shall look at Waec Physics 2013, question number 21 to number 25. And I am happy to be here. I also want to tell you that this edition is going to be super educative because there's a lot of calculations that some of you might have not noticed in physics that we shall be dealing with in this edition. Now don't forget that if you learned something from this video and you want to get more content from us that will better help you understand physics, click on like button. We can only link you or reach you by a like button. Okay, now let's get to number 21. A mass of a body of mass m kilogram rests on a plane inclined at an angle theta to the horizontal. The component of the weight of the body parallel to the plane is what? Now the one parallel to the plane. Now if you have an inclined force now here, the force acting parallel to the plane is the force acting against friction. That is the pulling force. So this is the pulling force and this is the frictional force, right? This is the normal and this is the weight. Now this one, I'm very conversant with this thing, mg sin theta. I've been conversant with it from secondary school days because I know that anything in inclined plane for friction can only be calculated with this formula majorly. Mg sin theta, that's my pulling force, okay? And that is I am very, you need to be conversant with it. So this is the force parallel to the plane, and this is the pulling, and this came from the, of course it came from triangle, right? Now from theta here, we know that the force acting here, the force acting downward is mg, that's your weight. But what is this part of the force? If here is theta, you know, opposite and what hypotenuse, that's sine. Opposite, that's sine, so it is sine here. So the force, and like, you know, for a triangle to find this force here, you need to actually do SOHCAHTOA. That's opposite of this angle here. That's opposite and hypotenuse. That is sine, and that gave you sine theta. So mg sine theta is what you have it, and that's the answer for number 21. Mg sine theta. Now number 22 says a quantity of water at 20 degrees Celsius is mixed with another quantity of water at 70 degrees Celsius. The final steady temperature of the mixture is 40 degrees Celsius. Determine the ratio of the mass of the cold water to that of hot water. Now this question is under thermal physics, and this question is heat. Now any question on heat has a master formula for thermal physics. Naturally it should be mc change in theta, but there's no measure of mass here. There's no measure of c, and that's specific heat capacity. It should just be theta, change in theta. So it is temperature that is changing, and what to do is this: total heat loss by hot body equals total heat gain by cold body. That's the first step. Now this is an interpret. Like if you are pouring, if you have a cold body and a hot body, now the hot body is 70 degrees Celsius and the cold water is 20 degrees Celsius, right? You have cold water of was 20 degrees Celsius and hot water of 70 degrees Celsius, and you now mix them together. What will be the, and the final temperature is what? Is 40. What is the ratio of change? But now you have here the hot water is actually the, you must do it this way: temperature of the hot minus the temperature of the mixture equals temperature of the mixture minus the temperature of the cold. Now what is the temperature of the hot water? That's 70 minus temperature of mixture is 40. Okay, that's that. Then temperature of mixture is 40, then temperature of cold is 20, and that's what I have here. 70 minus 30 minus 40 is 30, and 40 minus 20 is 20. Then what's the ratio? Ratio means division. That's 30 divided by 20 is 3:2, and that is the ratio. The simple answer is 3:2. Now remember how I got it? I came from hot minus mixture equals mixture minus cold, and that's the way I found the answer. I solved it through, and I got my answer 30:20. 30 equals 20, and that's 30 over 20, and that's 30 over 3/2, which is 30:20, and that is the answer for number 4B. Now let's talk about number 23. The mass of an empty density bottle, 30 grams, is 30 grams. Sorry, when mixed with a liquid, the mass of the bottle and liquid is 40 grams. Right? Now on heating the field through 40 degrees Celsius, the mass reduced to 38 grams. Calculate the apparent cubic expansivity of the liquid. Now when you hear the word cubic expansivity, something should come to your mind, right? Now you know we have done linear expansivity in school, area expansivity, and volume or cubic expansivity, and that's it. Now the formula for cubic expansivity is equals to mass of liquid expelled over the mass of liquid left times the temperature change, right? Now in the question we have empty bottle as 30 grams, filled bottle as 40 grams, after eating as 38, then temperature as 40 degrees Celsius, right? Now what is the mass of liquid that will pour over? Now if you have a liquid in the bottle, okay, and then you now put a mass into that bottle, part of the liquid will get what? Now we have the empty bottle as 30, then the bottle filled as 40. So the liquid expelled is going to become the gap between. Now after filling the bottle, the mass of the bottle is now 38. So the mass that flowed out is just the gap between the filled bottle and the mass of the liquid after eating. So you have a bottle full of an empty bottle and you weigh it, okay? Then you fill the bottle and it weighed 40, but the empty bottle is 30. Then you weigh it and it was 40 grams. Now when you finally eat the water in the bottle to 40 degrees Celsius, the mass of the water left and in the bottle is 38. Now what is the mass of the water that was gone? And that is 40 minus 30. That means the full bottle minus the mass of the bottle after eating, and that is the mass of the liquid expelled divided by the mass left. Now the mass left is just the difference between the mass after eating and the mass of the empty bottle. So the mass left is just going to become the mass after eating and the mass of the empty bottle times the temperature. Now the mass expelled is therefore 40 minus 38. That is the mass of the full bottle minus the mass of the bottle after eating, and that's 40 minus 38. Okay, then the mass left is going to become the mass after eating the bottle minus the mass of the empty bottle. You know, if you remove the empty bottle from the mass after eating the bottle, you are finding the mass of the liquid in the bottle, because you are now removing the mass of the bottle. It now become pure liquid, only the liquid minus the bottle, and that is what you have as a mass left here, times the temperature, which is 40 degrees Celsius. So the temperature is 40 degrees Celsius, and that's 40 here. Then 40 minus 38 is 2, 38 minus 30 is 8 times 40, and that will become 2 over 8 times 40 times, if you divide 2 by 8 times 40, that will give you 0.00625, and that will become, in standard form, that will become, you will move this point from here, 1, 2, and 3, 6.25 times 10 per minus 3, and that is my answer for the appearance cubic expansivity of the liquid, and that makes the answer for number 23 to be B. Let's check out number 24. A car traveling at 30 meters per second overcomes a frictional resistance of 100 Newton while moving. Calculate the power developed by the engine. 1 horsepower is 0.75 kilowatts. Now look at this now. Now this is just asking for power, right? But there's a problem here. Power is force times distance over time. We know that, right? But in this question, we have force, but we don't have distance. We have only speed. So that means you have to modify this formula of power into speed, and that will become, you know, force and distance over time is speed, and that is force equals force times distance over time, and that will become force times speed. So power can also be force times distance over time, or force times velocity or speed, and that is what I have here. Power is force times velocity. It came from distance over time, and that is what I have here. Okay, now what my force? My force is 100 Newton, and my speed or my velocity is 30, and that will give me 3,000 watts, and that is a power, or 3 kilowatts, and that's my power. But you must put the answer in horsepower. So that means 1 horsepower is from what we have here. One horsepower is 0.75 kilowatts, right? Then we don't know what horsepower 3 kilowatts will be. So if 1 horsepower is 0.75, then X horsepower is 3 kilowatts. So how many horsepower will be equivalent to 3 kilowatts? That's what we are trying to find. So we call it X. Now I will cross multiply here. That will give me X times 0.75. That's 0.75X. 3 times 1, and that's 3. Now divide this by 3. S equals 3 divided by 0.75, and that will become 4 horsepower. And that is the answer for C, 4 horsepower. Now the last question for this episode. the quality of a note on a keyboard. If you are playing a string guitar or a string instrument, the quality of the note depends on what? Now, is it on the frequency or the pitch or the overtone or the amplitude? This question is very, very simple. Now, is it the frequency? Now, actually, the pitch of a note, like I have here, I have a drummer boy here. This man is Mr. Bolaji. He loves to drum. Now, you can see him here. Now, as he's drumming, the pitch of his drum depends on the frequency of the strike that he made on the leather. But we are not asked about pitch here now. We are asked about quality. Now, what determines the quality of the sound is making? The qualities depend on harmony's intensity. Now, in the option, we don't have harmony, but you must also know that we also have harmony. Now, in the option, we have frequency, we have pitch, we have overtone, and we have amplitude. The word overtone means harmony. Now, harmony depends on harmony affects quality. The harmony of the drum affects the quality of the sound. Like, you know, if you are in the choir, we have what we call parts. We have tenor, we have bass, and we have treble, and we have alto, right? Those are called what? Parts, or we call them what? Harmonies. Now, harmonies, the more the word, if you are singing with only one part, you know, it will be good, but it will not be qualitative enough that if you have all the parts coming in. So if somebody is singing tenor, somebody is singing alto, somebody is singing soprano, somebody is singing treble, alto. Now, if all the harmony come together, it will bring in quality. So what affects quality of a note is simply the harmony, or the word overtone. So the word overtone is also the same word for harmony, and that is the answer for number 25. It is the harmony or the overtone that affects the quality of a note, and that is the answer for this session. And that brings us to the end of this session. Don't forget that if you learned something from this series and you want to get more content, click on like button. We have a lot to share with you. Until we see you again, guys, take care of yourself and bye for now.